Welcome. This video is about the Siphon project. I want to do three things. Number one, give you feedback on the project, summarize the recipe for doing great experimental work, and describe how your learning was measured. Feedback is all about how can you do better experimental work. So the goal of the class is learn to design experiments, conduct experiments, and present results. The first feedback refers to sub-goal number one, which is get technical knowledge down. And this feedback refers to any time you're doing a project that involves thermal sciences. So this would be a fluid mechanics, heat transfer, mass transfer, those types of subjects. And the feedback is use pi groups. In this particular project, that'd be like Reynolds number based on pipe diameter, the length to diameter ratio of the siphon hose, and the elevation head to pipe diameter ratio. And then report your results with pi groups. And the reasons for doing this is dimensional analysis always reduces the number of variables. For example, if you have 5 dimensional variables and you then form pi groups, you subtract the number of primary dimensions, so 5 minus 3, and you would actually reduce the number of variables that you have to vary during your experiment from 5 to 2. And so this is a huge amount of time savings. And then when you present your results with pi groups, they generalize to many more cases. So the results end up being far more useful for your customers. The next feedback refers to sub-goal number 3, which is apply statistics. Anytime you're presenting data, you want to present the central tendency. So describe the mean of your data, but you also want to describe the dispersion. And you can do this with the standard deviation or the range, and there's a few other techniques. And there's other ideas from statistics, using the ideas of a population and a sample, and introducing the ideas of accuracy and precision. Here's an example of how you might have applied statistics. We measured 15 samples. Our mean agreement between the math model and the experiment was 7.2%. We had a standard deviation of 4.9%, and our range was 1.7% to 13.8%. So you're doing two things here. Number one, you're describing the central tendency, and number two, you're describing the dispersion of data. And you want to put these kind of statistics in your conclusions and at the end of your abstract. I added one more tip here. Anytime you present data with a scientific method, you qualify where the data is. So you might want to say our Reynolds number range was from 1200 to 27,000, our L over D range was from 10 to 100, etc. But you don't overgeneralize the data. You just tell people exactly where your data was taken. So my observation, what I've seen in professional practice, is that only a small minority apply knowledge from their courses. And of course, you want to be part of this small minority, because this small minority is the people who are really good at what they do. And so the feedback question I want to leave you with is, how can I learn so that I routinely apply my knowledge in ways that give me huge benefits or help me do projects much, much better? Doing great experimental work is like baking a cake. There's a standard recipe. And here's the recipe. We'll go over this again. You always start by defining a really important, a really significant problem. And you get results that provide high levels of value to your end users or the customers of your work. And always we apply the scientific method, and this helps our results be understandable and believable. Step 4 is we figure out, we explain, we apply, and more importantly, we extend knowledge with our experimental work. And step 5 is you communicate what you did, why you did it, and your findings using the ways of the community. And the standard way is to write a report using the standard practice, which is IMRAD. Measurement of your learning on this project involves a few things. First off, there's a person who's done a lot of experimental work who really enjoys it and loves it. That would be me. And this person wants to be able to recognize the diamonds, the elements of quality, how to do good experimental work. And this person wants to have an instrument for measuring how well is the learning taking place. And this instrument is called a rubric. And so the sheet I send back to you is a rubric. Let me show you how that works. Question number 1. How well does the evidence, this would be the report, show that the student can get results that provide high levels of value to others? And so on the rubric, you'll see this dimension, and you'll see the weight, and I'm looking for a few specific things. Did you make about 10 or more comparisons of experiment versus a math model? Do you have clear communication of what your comparisons were? Did you vary the length, diameter, and elevation head and avoid varying only one factor at a time? So on your scoring sheet, you'll see a number like this, and I'm telling you what your level is, and this describes how well you're learning, and this ranges from 0 to level 8, and level 5 is full credit, so that's 100% in typical academic language, and from 5 to 8 is extra credit. You might also see something I've marked in blue, and that would be a strength, and if I mark something in yellow, that's an idea to consider for improving your next project. And I might also add a few comments. On the rubric, the second thing I look for is how well does the evidence show that the student is understanding the scientific method? And there's kind of a long list of things I'm looking at, but if you're hitting a few of these and seem to be grasping the idea, you'll go to level 5, and if you're getting a number of these, you'll go to level 6, 7, or 8, and if you get level 0, that means I've made a decision that the evidence is showing you're probably not yet catching on to the ideas of the scientific method. Dimension number 3 on the rubric, how well does the evidence show that the student is figuring out, explaining, and applying the collective wisdom of humankind? And what I'm looking for is your write-up, does it look like a professor wrote it, or does it look kind of like what you'd see in a journal article? And of course, it doesn't have to be anywhere near this good, but just kind of on track with this and catching on to the ideas, and you'd be up at level 5 or higher. Now notice here that I have the words "and add to." How well can the student figure out, explain, and add to the knowledge? I'm going to share with you a really big idea, and the name of this idea is discovery. Whenever you do high-quality experimental work, you're going to build new knowledge. You're going to find things that probably very few people know. And so one of the central purposes of your experiment and your report is to communicate this new knowledge in ways that provide value to all other engineers and scientists in the community. And this discovery process is what makes experimental work really, really fun. So in summary, you want to be paying attention, and you'll actually discover very new ideas. This is the most fun part of experimental work, and probably the most valuable also. The fourth dimension in the rubric, how well does the evidence show that the student can structure an open-ended problem? And you'll see some words here, but I like to look at this with a picture. On any project, a professional always gathers a great deal of information about the present state, so they really understand where things are. They define a goal state, a future state that is measurable, and that's where they're going to head. But the most important thing they do is they figure out, why would I want to reach the goal state? And this process of defining the present state, defining the goal state, and answering the why question is called problem definition. And this applies to any kind of problem that professionals do. And dimension number 5, how well does the evidence show that the student can communicate professional work? And all the stuff I'm looking for is listed out on the rubric. So I take each of the 5 dimensions and I average them using a weighted average, and you can see the weights on the scoring sheet, and I'll come up with an overall level of learning. So let's say you're at 3.5, and then this has a weight of 10, so 35 points would go over here. Then I look at lessons learned, and I measure the level of learning there. So you'll get a number from 0 to 8. And let's say your present level of learning, your present ability to do lessons learned is level 4. So 4 times 1 is 4. And then I simply add up the points. So 35 plus 9 is 44. And that's the number of points that go in the gradebook. That concludes this talk. I hope this has been useful to you. We'll see you next time.